Hey y'all, it's Sean of Math Swap Tutoring with another Calculus 1 tutorial. And in this video, we're going to talk about what's called the vertical line test. Just remember, if you are looking for tutoring right now, you can schedule a free consultation at Calendly, CALENDLY.com /math swap tutoring. That's all one word. I shouldn't have left a space there, but hopefully you get the idea. And also remember that you can find these notes. The notes that I use to make these tutorials, I make them freely downloadable to my subscribers. If you go to Math Swap, sorry about that, y'all. Math Swap tutoring.com /subscribe. SCRIBE. All right. All right. Anyhow, so we're talking about what's called the vertical line test, and this is for functions. All right. So if you watched previous videos on functions, now keep in mind this is not, functions aren't just a calculus thing. This is actually something you start learning about in Algebra 1, but it becomes extremely important in Calculus 1. So all the vertical line test is a simple test you can do whenever you have a graphed function to help you determine whether or not that function is a function. So say, for example, you have this here, you have an XY plot that looks something like this. Of course, you have the X-axis, you have the Y-axis, and then you have some function that looks kind of like this here. All right, so all the vertical line test is this. So basically, if you have a graphed curve and you want to determine whether or not it is a function, you should be able to draw a vertical line anywhere on this graph that it crosses over the curve, and anywhere it goes down, it only passes through the curve one time. So if you can say that that's the case, then what you have is indeed a function. So this is a function because you can literally draw a vertical line anywhere on this XY plot and it crosses the curve one time. Okay. So this passes the vertical line test. All right. So let's take this a little further, erase this, and let's draw an example of something that would not pass the vertical line test. So say, for example, you had this curve that kind of came like this here. All right. So remember, with the vertical line test, you have to be able to draw a line through any point and it cross. And some of these aren't perfectly vertical, but hopefully you get the idea. And it should pass through one time. And so you see that's the case until you get over here and you have a situation where a vertical line intersects your curve at two different points. So say, for example, right here you have this point is here, hold on a second. Let me get my black thing here. So say, for example, so this is x equals a. So this is a right here. So this coordinate is a c and this is a b. Remember, this is the x coordinate and this is a y coordinate. So that would mean this is b right here. And then this is c. All right. So basically, you cannot have a function here. Graphically, you see that because it's the vertical line test that it fails the vertical line test. But basically, to explain it, when you have a function, you cannot have a situation where for a given input value, in other words, for a given x value, in this case, x equals a, you have more than one y value, more than one output value, which is the x equals b. So you plug in. So for example, that's just saying for f of a, you have, so the function at point A is equal to B, and the function at point A is equal to C. And you can't have that. That's not a function. So basically, to have a function for every input value, again, that is the value that you would put into here. For every input value, you should have only one output value. Okay, you can't have two. And that's what you have here. When you plug in the function at point A, you can get B and you can get C. And that means that you don't have a function. Okay, so let's look at another example, an interesting example. A couple of examples here. Let me see. Trying to find the eraser, y'all. Just bear with me for a moment. Okay, let me erase all this extra stuff that I put here. All right, so check this out. What if you have a function that does something like this? All right. So basically you have this this point, this curve. It's not a perfect curve. So does this pass the vertical line test? I should have drawn it in red like I had been doing, but it's all good. Okay. Sure. But technically, and this is supposed to be a straight line, like a discontinuity, I believe. So basically, this does not pass the vertical line test because you have like this perfectly straight line where literally at x equals whatever this point is here, the line includes every point, every y point here. Because at x equals whatever this is, let's say that x right there is equal to negative a. So the function at f equals negative a, y can be anything along this line. It's every point along this line. So that means that this is not a function, okay? Now let's look at this other example here. Erase all this stuff. So let's say that you had something like this. Make sure I draw this well. So this is equal to x equals y squared. So if you recall, if you remember the way some of your common functions look, this is like a parabola, except that it's not like this, like parabolas usually are, like straight up and down. It's to the side. And if you look at this equation here, you can kind of see why, because this one, the typical one, is y equals x squared, where x is the input value and then y is the output value. In other words, x is the one you plug into, and then whatever you plug into x gives you your y. And this example is flipped. So now you have x equals y squared. Now y is the input value, okay? And then x is the output value. In other words, you plug in for y and then you get an x value. So next question is, does this pass the vertical line test? Now, if you had this situation here, and I drew this pretty bad, these aren't supposed to go straight up like that. Typically, it's just kind of more so, it's a more so U shape with a gradual going up, but it never gets totally straight. Does this pass the vertical line test? No, it doesn't, because you cross here and you cross here. Right. But this is an interesting situation. Sorry about that. But yeah, this is an interesting situation here, because even though this does not pass the vertical line test, An interesting thing to note is, and I erase part of this, so let's erase that like that, erase that there. Interesting thing about this here is that this x equals y squared is comprised of two functions. So this is actually, this line is equal to y equals x. I mean the square root of x, which if taken by itself, it will pass the vertical line test easily, right? And that bottom piece, we'll erase this for a second. That bottom piece that we saw is equal to, and I should have made that yellow, it's equal to y equals negative square root x. Okay, and so this passes the vertical line test by itself. Now, when they're x equals y squared, they don't pass the, they're not a function. But separately, those are each functions. And how did I know that these were y equals square root of x and y equals negative square root of x? Because when you look at the original function I had, the x equals y squared, all I did was solve for y. I wanted to find y. So you take the square root of both sides. And so then that becomes y. I said y, but I wrote x. So then that actually becomes y equals plus or minus the square root of x. I mean, not the, yeah, plus or minus the square root of x. And so remember, it's plus or minus because when you take the square root of y, y could end up being positive or negative, because whenever you square it, it's going to be positive underneath. So that's why you say positive or negative, because it doesn't really matter. If you square both sides of this, then it's still going to be x equals y squared, regardless of whether or not this piece is positive or negative. So that's why you say positive or negative. You have to consider both. But anyway, that's an example of a situation where if you have where it's a non-function that is comprised of two functions that are, if taken separately. Okay. All right. Hopefully that's clear. Remember, if you want a copy of my notes, subscribe at mathswaptutoring.com/subscribe. And also make sure that if you actually want to schedule a session, that you schedule it at calendly.com/mathswaptutoring. This should also be in the show, in the video notes. Or you can call 478-254-0515. 478-254-0515. All right, thank y'all for watching, and make sure that you subscribe on this channel and follow my other videos, y'all. Take care.